All right, let's do some adding and subtracting of rational expressions. Specifically, the example we're going to do is subtracting. If you recall how to add just regular old fractions, we pretty much follow the same rules. We have a couple extra steps because we're dealing with polynomials rather than just numbers. So, first thing you have to do is factor the denominators in order to find the least common denominator. So that's the key. Your fractions have to have a common denominator. Once we determine the least common denominator, remember we create two equivalent fractions that have the same denominator. We then add or subtract the numerators, denominator stays the same, and then we simplify the resulting rational expression if possible. So let's look at an example. All right? We're supposed to subtract these two rational expressions. If you notice, the denominators are different. So first thing we need to do is we need to factor the denominators, if possible, so that we can come up with the least common denominator. My first denominator is a difference of squares. Okay, so if you remember, factoring a difference of two perfect squares factors into two binomials with different signs. Remember, they are called conjugates. What do you square to get x squared? X. What do you square to get 9 is 3. Okay. My second fraction, the denominator is x minus 3, cannot factor that. Therefore, it is prime. So it's x minus 3 times 1, basically. All right. I'm just going to copy down my numerators. Okay, now we have to come up with the least common denominator. So if you recall, the least common denominator of rational expressions is a product of each factor, the most number of times it occurs in any denominator. So in my first denominator, I have a factor of x plus 3 and a factor of x minus 3. So in my least common denominator, I must see a factor of x plus 3. Because it only occurs once in the denominator here, it does not have to occur in both. Okay, just one of them. And then I have a factor of x minus 3. So my least common denominator must have a factor of x minus 3. But it occurs once in my first fraction and once in my second fraction. Therefore, it occurs once in my least common denominator. So the least common denominator is the product of x plus 3 and x minus 3. So I'm going to create two fractions that are equivalent to the given rational expressions that I have right here. And I want them both to have that common denominator. Well, the first one already has the common denominator, so the numerator stays the same. Okay. In my second fraction, I don't have a common denominator. I have x minus 3, but I do not have the factor of x plus 3. So that's the factor that I'm missing to have the common denominator. So we're going to multiply numerator and denominator by that missing factor of x plus 3. Remember, it's like multiplying by 1 because x plus 3 divided by x plus 3 is 1. So I'm not changing the value of the fraction. All right? So that means that my 5, or my x and my 3, both get multiplied by the 5. So I need to distribute that 5. So I end up with 5x plus 15. Okay? Now that I have a common denominator, we go ahead and subtract the numerators only. Remember, the denominator stays the same. So you have to be careful when you're subtracting, okay? Since what I'm subtracting, 5x plus 15, has more than one term, remember we have to use parentheses so we make sure that we subtract both of those terms, both the 5x and the 15. So ultimately what I need to do is I need to distribute that negative sign through those parentheses. Okay, so that make sure I subtract both of them. So I have 9x plus 3 minus 5x minus 15. I distributed the negative. And now I can just combine like terms. So 9x minus 5x is 4x. 3 minus 15 is negative 12. Keep my same denominator. Okay, and then our last step is in the denominator, or excuse me, in the numerator, we have 4x minus 12. What I have to ask myself is this rational expression simplified? Can 4x minus 12 be factored? And if it can, does it have a common factor with the denominator? So you always have to check that in the very end. And yes, 4x minus 12 can be factored because both terms have a common factor of 4. Okay, so I'm just simplifying my resulting rational expression. If possible, it is possible because I notice numerator and denominator have a common factor of x minus 3. So I'm going to divide out x minus 3 from both the numerator and denominator. And I'm left with 4 over x plus 3. It's my simplified difference of those two rational expressions.